Hi everyone, my name is Bernie, and this is actually the first time being at Conf Talk. Really appreciate the sponsors and the host to make RubyConf happens every year. So actually, how many of you are the first time being here? That's great. All right, it's great that everyone enjoys RubyConf. So we need that spirit in our community. Today, I'm here to present about some performance tips, which I've almost seen every time working on a web project. Maybe some of you might have heard it before, or some of you don't, but I still hope everyone can enjoy their time here and meet new developers. Could also be great. Let's give a short introduction to myself. So, who am I? Oops, sorry, not this one. That's my secret identity. I'm currently a software engineer working in a small startup called EasyShip. As the name indicates, we are actually a platform that provides global logistics solutions for e-commerce. And you can find me under those Twitter or GitHub usernames if you would like to have some further discussions with me afterwards. We are mainly based in New York and Hong Kong. There are a few topics I would like to cover today. Most of them are listed above, like working Ruby with API, database, and other network services. Of course, no matter how fast Ruby is, we still have to write it properly to make it reaches to its full potential. So talks about Ruby itself are also important. When we speak of APIs for a web app running after a few years, which parts of it really affect business? I mean, what do we really care about? Is average response times what we are looking for? Maybe or maybe not. There's really an old article talking about problem with averages for measuring metrics. Like for a combination of 1,000 and 200 requests in this example, the average looks absolutely acceptable. However, that wouldn't sound correct at all, right? Actually, I'm not sure DHS has the right calculation here, but you get the point. So that might end up in a very diverse group of people that can feel your site to be either extremely slow or extremely fast, which of course could be a problem that though slowness still happens, but you have no awareness. When you look at the average, which seems very okay at first glance. So every company should be using a performance monitor tool in production. Newrec, Skylight, Scout, or AppNeta are all respectful SaaS services in the industry. We can rely on most of them or personal ones and try finding your desired metrics. I know Scout also sponsored in RubyConf. Maybe we can get for longer trial periods from them. So what really matters? We could always look for popular endpoints and slowest response times to prioritize your APIs that might affect your business value. For example, Skylight automatically measures the combination of these factors to determine which endpoints are having the most adverse effect of your users with agony points. Of course, we can do this in other measuring tools too. So always make sure what you are looking for to optimize and focus your business first. And here's a little subtopic from my overview. I'll be talking about Web API first. The icons look pretty cool. I hope it won't violate any IP property because of this famous TV show. So if it does, please help me Photoshop out of the recording things. When we talk about RESTful, a simple CRUD actions are always defined as default most of the time on implementations. But what if we look at the actions like this for several years? Do we still find them useful if we have an orders page that allows multiple selection for updates or creations? Some still might stick to the existing APIs to use the same request, but doesn't that make linear requests for every update actions? So from time to time, we always need to review our APIs to see if it needs change to make sure we don't have N+1 network requests for our applications. Of course, not suggesting every scenario needs to be changed like this, But we got to know that use cases will grow with your interfaces. So we should always retract API logic in the long term. But what if we need to import or update even more data that might not from a web request, but from CSV or web crawler? Even small update or insert from an ORM is a single SQL statement to your database. Every request to database takes time too. Besides running a raw query, we always have tools like those gems to help relieve the slowness of your queries if you encounter millions of records. So for a Rubyist, making sure what runs under your Ruby code is crucial in order to have the best performance solution in mind. And next, I would like to talk about a few more examples on Ruby code that relates to database, and also what it does in the paginations. When talk about paginations, I mean something like this showing to the users. I suppose everyone is familiar with the look of this, maybe just in a different formats. Speaking of how paginations getting those page numbers, it actually issues a count query on your view pages, or probably if you need to show them. You also need to include them in your APIs. As far as we know, counting count statements in a large database sets is rather slow and not very efficient. When I look up on Google, I suppose it's still an issue these days, or I'm not sure if it's being resolved in some GEMS implementations or not. For example, when I look at the Kaminari gem, it has an implementation without issuing a count query, but only keeping the previous and next pages in the view. I suppose we can actually show the numbers of page collection we currently have. What I really mean is that we only have those two buttons, previous and next, showing to the users. But what about the total pages that user is currently navigating at? And of course, the current page number. So I wonder, is there a way to keep a user navigation intact, but not impacting the overall site's performance? I used to come up with a solution that if we can limit numbers of count we fetch, we can actually regain the performance back from a large dataset records. Imagine we are showing 10 records per page, and we only want to display the maximum 8 of them on your page native view. What's the point of issuing a count query on all datasets? Why can't we just fetch the maximum of 80 records instead? And this kind of approach really works quite well. I mean, keep those numbers here is hard, but we could still make it. I used to encounter an index or search page I can really quite remember. We not only have different speed on our servers according to different size of data they have or search results, but we need to still show them the paginations. And that's why we have ups and downs on our metrics. After deployment, we could not have a consistent result to fetch the desired count, and also keep the navigations of pages intact. Which of course is kind of cool, because this is what becomes after our deployment. A really straight line. Of course, count queries still exist, but extremely fast. This is what I'm talking about. One of the famous ORM patterns interacting with database is active record. I won't cover something like what issues a query or not in active record relations, since it's also quite important for us. But I would like to show an example I found it interesting when working with the iterations. As far as we know, active record provides batch processing of your database records. The intention is to optimizing the memory saving when you loop through a very large datasets. You can control of how big it is, which of course even provide few options for you to limit the batch size. When you work through the migration and want to backfill the data, using update in batches also provide the benefits of not locking the whole table. But there's actually a time when I work with a system structure that actually made it quite slower and inefficient. And what's the case? I always wonder why our rake task finish up so slow even when we have our processing unit put into job worker. When encounter tables with UUID, I've dug into the logs and saw that the batch query was actually ordered by UUID in an interesting fashion, without the offset. I suppose it's trying to fetch the order of the primary key to set the batches. The results are quite slow, which takes about 10 seconds for each batch. So I looked up the documentation, and by default it actually is. And we can't seem to change our target column at the moment. But wait, do all UUID types are sortable? For example, if we are using UUID version 4, according to the Postgres engine and to its documentation, which is actually in random, unlike Mongo's object ID, we can't quite know what order it is if we are using it as the primary key. But I still wonder what makes the current query work since we have all the data query fetched, but just in a very slow process time. By looking up a few of the sources I could, then I saw there's a custom implementation from GitLab that allows a target column to be specified in batch functions. This is actually what I was looking for. Maybe need a little modification, but it does the job for us. So later I changed to a sortable column like created. The speed seems to come back to normal again, down to less than a second. Maybe not correct enough and need to do some tweaks. I suppose this is a way better result I see compared to the previous one. Next, I also want to talk about some libraries besides Active Record that also connects to a third-party storage like caching, for example. There are many types of caching strategies in web, but I'm not going to talk about them all. So I'm just going to fast forward to the one that actually aims at caching without any network condition. There's particularly a small example of a local cache I would like to talk about. So we know caching in Rails is very common. Even more natively, we use Rails cache that can connect to any storage backend we want. The strange thing is, do we always need this cache when something can be stored locally in a file or a constant, or even a YAML file? Even the logic seems kind of clear that we need cache for a certain table structure. And the table structure can be either calculated results to allow our operations to modify the data. So there's a cache we can expire to reflect the results. This is a case when our operations can actually change something in a Google Doc, and we try to cache the result from it to allow a globally accessible text percentage to be used in our price calculations. But actually, when we define a fixed table, do we actually want it to be dynamically refreshed when it's only fixed for a period of time? Or actually, it's like fixed for years? As far as we know, every country's tax calculation won't change frequently, and even they stay years to have the same tax structure. So interestingly enough, why bother to have an expiry cache that we can use? Instead, we can just actually define in a YAML file or set it to be a local constant. This is way more accessible if it's a globally fetched table. Sometimes we say no code is the fast code. The example here can also see this in an alternative way, like no connection to any backend might be the fast connection. So, well, fast code, I suppose. To make this theory even more promising, I also benchmarked the result with a Ruby tool, which I'll mention later. A result shows that using Rails cache can be 100 times slower than locally accessed table. Even we have a Redis node in our same Kubernetes cluster network, the connection still takes time. But of course, this methodology won't fit in every use cases. But it's a good reminder that the long cache expiry is something that you might need to reconsider what actions of software design you need to take. So let's talk about Ruby itself. Besides Matt powering up Ruby 3 times faster in Ruby 3, In the meantime, we also need to check our code quality to make sure if they are reaching to its full potential. When we talk about benchmarking, there are many ways we can do it. If there's a partial code or we already know the detailed problem from online monitoring tools we've mentioned earlier, we could actually use some good tools to help us look into it. Even small tricks can help the contribution to open source even much easier and valuable. Instead of natively using the internal benchmark library, I would recommend using benchmark IPS or IPSA. They are very easy to use, and the later one even provide a memory allocation indicators for the comparisons. So why not choose the native one? Actually, when we work with the benchmark library, we can only run once or few iterations by design with BM or double BM. Of course, inside the benchmark, it shows the time factors. I can also run iterations inside, but I need to actually provide the iterations count to make sure it is testing correctly. But I don't really know how many times I need to choose. For example, in the documentation, we see that it's testing against 5 million times. But I'm not sure if that's actually a number or what number I need to choose to test against other cases besides this one. So this is actually why benchmark IPS is much more easier to use, because one of its features is automatically figures out how many times to run the code in order to get the desired results. Like I've mentioned earlier, tricks like consonantizing extra operations in the process can boost a bit for performance. But how do we actually persuade code owners to believe it? This kind of benchmark actually helps. Take the recently quite famous pagination gem, Paging, for example, which they claim to be the fastest pagination plugin in the market. Interestingly enough, I just removed the conditional checks that actually runs in every page initializer. We can test with benchmark IPS easier. No manually enter iteration count. So just put your code inside every block you need and provide your testing titles. The result can be quite promising with confidence level, about 20% faster than working with the original one. The most notable example I would say is SQL Gem, which is another alternative for Active Record that actually did a lot of constants in the libraries, which one could never think of. If someone wants to dig into a little deeper, you can always take a look at this gem. By testing a theory, one can contribute easier with performance. Everyone can actually make the whole community gem faster along with Ruby itself. And let's talk about some flame graphs, how to quickly generate them, and also tricks to identify some problems. I suppose most of the people are familiar with it, probably use it before. Maybe sometimes working with it might not be easy because there are several tools for us to use it. When you look up the forums or articles, they suggest a variety of tools for you to generate them. As you can see, Ruby communities are strong, but what can be the easiest way to see it? Actually, I would suggest just use the reg mini profiler. Sometimes we use it to observe SQL query on an all-in-one Rails application, but rarely on an API. There is even an issue left open and no one seems to answer on how to actually perform a full observation on authenticated APIs, since we can easily just display in a web browser like a web page. Actually, the reg mini profile already provides params like frame graphs or memory profile for you to observe in your API endpoints. If you actually know which one from the modern tools you are working on, like you can even use it in your personal API tools like PAL or Postman. And this is the example from the PAL API tools. So if you are using one of them, there's always options for you to transform requests to a web page. Maybe you can navigate the web page. So how do we retrieve it? Simply export just to a HTML file is a good option to navigate in these flame graphs. You might see some of the internet sources combine several tools for you to export to an image or compress to into different formats. I'll say that will take too much effort and steps. So I believe this is the easiest way to see the result immediately. When we open the frame graphs in HTML, we can't actually see anything relevant at first, just something like a pyramid here. There's no need to hesitate. Those different colors mean different methods code stacks built on top of each other. And the execution time goes right to the end of the graph. Imagine a request comes in. It has to go through rack middlewares, routes, and inside controls, something like that. Functions execute inside functions. So that's why they persist at the bottom of the stacks. So most of your own code start at the top of the traces. If you are experiencing tracks with similar cars scattered on the forwarding timeline, that might result in a very efficient code or N+1 queries occurring in your time of executions. So if we see something like this, how can we observe it through this HTML file? Actually, it's more than meets the eye, since the gem author took time and rendered these files. Of course, it comes with an option that we can actually zoom in the stack traces for us to observe better. So when we zoom in, it can actually show what methods are being called and probably which ones are being called several times. For me, I would consider those inefficient, and we need to some way to optimize these functions to reduce overhead of our program. And that's actually how easily you could observe a frame graph with just few clicks to it. So do we need to verify it? Of course, when you're trying to optimize from what we mentioned in the first section, accessible APIs from clients but slow response times, you can always use small load testing tools to test, so that we can experience what clients feel from our websites. For example, I'm using Siege to test different versions of our code base on test servers with the same setup. These actually downloads a faster web experience than before on the same concurrent user settings. When we load test, we should not rely on how many requests we can hold on scaling out. We need to also look for how each server can currently handle the request, so that we can optimize our each server potential instead of wasting our money on resources we don't need. Of course, there are always few things to be aware of while working with legacy applications. Since your APIs won't be as simple as a new app you started in the first place, some might grow very large or involve different modules to be called. So your performance might vary on what you've sent to your APIs. So I would suggest always take the most common set of parameters, also the slowest one due to your metrics, to optimize as your first priority, so you might not miss the slow codes that actually needs to be looking at.不好意思. So I would call it an end from here. Happy hacking, everyone. Thanks for listening.
好，因为 Bernie 是台湾人嘛。
哦，对啊。
对，好，所以呢，大家现在有一些时间可以，没有，我想说大家可以用中文，可以用英文来问 Bernie 一些问题，因为我们现在大概还有10多分钟的时间，所以有没有朋友想要提问的？我们现在可以举手。好，来，
你刚刚讲到很多 profiling 的工具，那很多前进要 profiling 其实是在有巨量的资料的情境下，所以可能是在不大的环境，才会有这么多的资料量，会有效能的艺术出现。对，那是怎么去在开发环境或是在测试环境重现出这样子巨量的资料，就是真正的 profiling 之后的结果是否有效？
可是 profiling 的结果通常都是 因为你正式上线才能确定这件事嘛。可是假如你 local 假如能 replicate 的东西，代表你 production 一定有部分的资料，你可能已经在可能 New Rake 或者什么已经收集好了，那你可以重现这些资料，至少可以，我觉得至少你可以在 local 呈现出来啦。就是应该没有到呈现不出来的时候，因为毕竟你都知道问题在哪里了，对不对？那呈现出来，代表就是你上 production 再验证一件这样而已，这样，对吧？
问题 ？Do you have any questions that you would like to ask? Bernie, please raise your hands. Anyone? Yes.
喂，请问那个火焰图就 Frame Graph， 它有什么看的方法吗？
就像刚刚讲，它其实底层比较多是一些像 Rails 预设一些 middleware， 它在执行的东西。那很多function它都是看入在里面的，那其实它只是一层一层在内部迭代执行这样。那其实因为假如像刚刚我讲那个方法，假如你从 API 的一些POW 或者是 Postman 去绘出来 HTML 的话，那其实很方便。它其实可以去zoom in那些资料，那些资料其实都写着一些你的可能程式执行的一些 function name， 那会比较容易去看到你可能遇到的问题是什么这样。
可是我自己那个实际去跑过的结果就是有一大堆方法，然后就不知道怎么去定位这个问题。
因为假如你一大堆方法都是重复的方法在那个图片里面的话，代表你可能一直是重复执行某一段 code， 那可能这个就是你要看你自己的 code base 到底是不是有没有一些 loop 是不必要的东西这样，对啊。
这边还没有什么问题，我们应该还可以再问个5、6题都没有问题哦。对，大家要好好把握。好 ，OK， 好，真的都没有问题了吗 ？Bernie 有没有要再补充什么的？
我想一下。
好，Bernie 有没有什么其他的可以再跟我们分享一下的？因为我们还有10分钟的时间。
等一下，我预计 Q&A 会长一点，就好像比较短。
快点来，大家有没有问题？好，来这边。
Hi Bernie， 你在跑火焰图的时候，你怎么选择 profiling 的 mode？ 例如 CPU time 或者是 execution time？
应该根据你当时想要测的目的是什么吧？对，假如你在那个 monitoring tools， 假如你遇到可能 memory 的问题，那你可能就是用 memory 的 profile 去验证这件事到底是不是在 local 可以呈现出来的，然后再做比较好的效能调角的动作吧。可是我想问一下大家，就是大家都有在用那个可能像 New Rake 或 Promote APN 的 tools 吗？应该都有吧。对，那其实很多东西要验证这件事都是先看上面，因为 production 的资料是比较完整的，那大部分第一步的验证都是先看上面可能你遇到的问题这样。可是 New Rake 可能比较麻烦一点，因为它很多 dashboard 都自己去调整，那当然调整到你想要的样子会比较有趣，就是这个过程可能是会比较不一样的。对，因为有些像 Scout 或者 Skyline， 它自己本身就内建一些，它就会告诉你这问题是什么。可我不太清楚，假如你问题都解决完，那这些 tools 到底是要不要还是什么，就是可以丢掉还是？对。
去追问的。好，站着的朋友们有没有什么问题想要提问的？看到好多人站着。好，都没有了吗？好，那 Bernie 还要补充什么吗？
应该先这样。
应该 OK 哦。好，那我们再。